Okay, so it says, suppose it is suppose it is known that 11% of students at a large university live in dorms. In a random sample of 500 students at the university, what is the approximate probability that at least 14% of them live in dorms? Okay, so what do I know? I know that this is a problem to do with P.
Profesora, ¿está ahí?
No me escuchan. Sí. Can you see me? Hear me? Do you hear me?
Sí, ahora sí. Resolví el 1. Bueno, creo que, como yo supuse, creo que es B, pero no estoy segura.
Okay, so let's see. So for number 1, we're going to use what you learned in Unit 5, which was the binomial distribution, right?
Mm.
And the binomial distribution is about a variable x that is binomial with parameters n. What would n be? NP. What would x be? How would you define x? What is the variable that we're interested in?
En la B, ¿no?
No, how would you say it? What is the variable? What is the variable of interest? The variable is counting the number of students that live in dorms Got it?
Sí.
N is the 50. Okay, so you have to say here, out of 500. And the probability of living in dorms is given 0.11. And X would be 0, 1. It could be up to 500. Correct?
Sí.
But this question doesn't apply the binomial distribution exactly. It applies it in approximation. So that means you have to try and approximate that the probability is at least 14%. So at least greater than at least 14%. That's what you want to find out. Let me fix this because that's what you want to find out. And you want to find an approximation. Okay, so the question didn't ask for the exact value. To be more than 14%, oh, sorry, not X, but I have to say for 14%, actually, let me fix this. Let me fix this because what is 14%? What's 14% of 500? What's 0.14 times 500? The 70. So it's saying, what's the chance that more than 70 students live in dorms? 70 students or more live in dorms. That's what it's saying. So if you were doing this exact, if you're trying to get the exact probability, you would have to calculate the probability for you would have to sum the probability for all of those. But it doesn't say exact. It says, what does it say? But it says approximate. So to calculate this approximately, you convert X, which is binomial, into X approximately normal. How do you do that? You do that with the theory. So what I teach you to do is, since we learn about if converting X into the normal distribution, I also taught you about X over N. I'm just going to show the results. What is X over N? What's X over N? Let me do it here. So this is P. P is the true proportion. What is P hat? The sample proportion. The P is given to you. So you're told by God or by a previous set of studies, you're told what P is. In this case, P is 14%. The sample proportion is computed from the sample. Let me be clear that, I mean, you could be given that too, but the point is, this is a given parameter. So what we're going to do is talk about the proportion where X is the count. It counts the number of students who live in dorms, the number of successes in 500 or N trials. X would be distributed normal with a mean of n times p, and a standard deviation of n times p, 1 minus p square root. So you should have seen this. But also, we know that p hat, which is equal to x over n, is also approximately normal with a mean of, so if I divide x by n, I have to divide both of these by n. So this is going to be p, and then this one turns out to be p1 minus p over n square root like that. So what I'm going to do is use the information given, and I'm going to create the distribution as a normal, and then go back to unit. It was in unit 2, or yeah, unit 2, we learned about the normal distribution, right? So that's what we're going to do. We're going to make this normal approximately and use the results. P hat is approximately normal. P is 0.14. No, sorry, not 1. 0.11. And the standard deviation is P times 1 minus P over N square root. And once we have that distribution and the mean and standard deviation, we can answer the above question for P hat greater than 0.14. We could have done it also for X greater than 70, but I teach you how to do it with the proportion. It's just a little bit neater. So now we calculate probability P hat is greater than or equal to, because it's at least 0.14. And I want to standardize it. How do I standardize it? I standardize by, I turn this into a Z by taking the value 0.14 minus the mean of the variable divided by the standard deviation of the variable. I hope that's not confusing to read. So what's the mean of the variable? We have to use, this is the mean. And this one, we have to simplify this a little bit, right? So I get 0.0139. I usually tell you to keep 4 decimals. So I'm going to just make it, it rounds to, well, I'll write the whole thing, 1.3992855. You can put the whole thing in there, or just 0.01340. So this ends up being Z greater than or equal to standardizing 0.14 minus 0.11 divide 0.0140. And what do you get?
A mí me sale 2.14.
Yeah. Did you get that before?
Anterior, entendí, o sea, el paso que yo más o menos yo creo que brinqué como tal fue el de simplificar o el cambiar, como que ese paso no lo hice.
Mm, okay.
Muy
So,
directo.
pero ¿te parece bien? ¿Te entiende?
Sí, sí.
Okay. So now go in the table. That's all. Or Excel. Well, go to the table because on the test you have to have the tables. You're only going to have the tables. So we draw a picture. We're going to go this way. We go to the table. Let's see if I have a table here. Okay. So here, what was it? 2.14, right? So we look for 2.14 and the value is this one. So what does that give you? That gives you the left side. So you get 9838. So that means to be greater on this side, it's 1 minus. And that should be the answer. So 0162? Yeah. How is that? So let me take this with me.
Mm.
1 second, Natalia.
Ujú.
Okay, I'm back. So the answer is 1.62, which is B. Or option B. Is it correct? Let's see. Oh, I'm checking on my computer. Sometimes I solve these in my own mind and, oh, I got to do the whole thing. No, forget it. Anyway, pretty sure it's correct. Let's see if they let me pass. It doesn't give me the result. Anyway, I'm pretty sure it's correct. Okay. Okay, so let's try this one. This next one, there are 4 patients in the neonatal ward of a local hospital who are monitored by 2 nurses. Suppose the probability at any one time of a patient requiring attention by a nurse is 0.3. Assuming the patients behave independently, what is the probability that at any one time there will not be enough, anyway, nurses to attend to all patients who need them? There's a similar problem in the exercises that I did. So why don't you try that one for 5 minutes? I'll give you 5 minutes. Okay, Nicole, how did it go? I mean, Natalia, how did it go?
Regular, es que como no tengo, o sea, no me puedo dejar llevar por la tabla de distribución.
This
Pero
one?
dejándome llevar así como que yo creo que estoy entre la C y la E.
Okay, this is the way I'm gonna do it. Can you see? Yeah?
Sí.
So I know it's a binomial because I just know, but if you didn't know, you write down X and PK, and you see if you can account for all of these things. So there are 4 patients, so let's make that one N. And we're gonna look to see that there is not enough nurses. So X, well, okay, so we got to be this, the problem with this is that the actual variable isn't clearly displayed there. If I was to define X, there's 4 patients requiring attention. So number of patients requiring attention is really the variable. And it makes it a little difficult to see because we're used to reading exactly the variable in the problem. So number of patients requiring attention out of 4. It's always like that. The sentence is always number of successes in N independent trials. That's always the sentence. So I have here successes and in or out of, this is in N or out of, I can write that as out of. What would P be? What's the probability? See, now I can see P is the probability of success. And what's success? Success is requiring attention or patient requiring attention. So you can practice identifying the variable. So it means that X can be 0. Don't ever forget the 0, 1, 2, 3, or 4 patients. And the possible number of patients is either no patients require attention, 1 patient, 2, 3, or 4 patients require attention, or some combination of those. What is the problem? So the question is, what is the probability that at any one time there will not be enough nurses? So you have, so this is confusing, right? Because there are 2 nurses. You have to translate this problem into successes, into the definition of requiring attention. So how many patients would require attention for there not to be enough nurses? So there's an assumption underlying here is each patient requiring attention needs only 1 nurse. So the problem with this problem is just that there's so much information you have to sort out. But it's pretty straightforward when I explain it. So For there not to be enough nurses, how many patients should be sick or requiring attention? If 2 patients are in having an emergency, you have enough nurses, right? Because we have 2. If 3 patients require attention, do we have enough nurses?
No,
Right. If 4 patients require attention, do we have enough nurses?
tampoco.
So that's why K is 3 and 4. So we have to calculate the probability for K equals 3 and K equals 4 and or X equals 3, X equals 4 and add them together. So let's do that here. So to make the probability X equals 3 plus the probability X equals 4. And I'm going to do one at a time. And when I make the calculation, I say N is 4, choose K, and then the probability of success. Oh, I didn't write it down. What was the probability of success? The probability of needing attention was 0.3. Right here. So 0.3, 30%. Oh. 0.3. Hold on. Okay, 0.3 success and 3 successes. And then the failures would be 0.7 to make 1 failure. For 4 successes, it's 4 choose 4, 0.3 to the 4, and 0.7 to the 0. And then to put it in our calculator, we take 4 second function NCR 3, and you can keep going. You can say equals, so that's 4. You can write it down to simplify. So that's 4 times, I'll start over. 4 second function NCR 3 equals times 0.3 to the power 3 times 0.7 to the power 1 is just 0.7. So that's the answer for that one. And then 4 second function NCR4 is going to be 1. 4 choose 4. If it's the same number, the number of ways, what does this mean again? This means the number of ways of seeing 4 successes out of 4 trials. And there's only one way to see that. Success, 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 success. So that will be 1. And then this will also be 1 because anything to the power of 0 is 1. So all I'm going to do is calculate 0.3 to the power 4. And I get 0.0081. And I add to it 0.0756. And I get the answer 0.0837. And I look at the options. It's E. You said D or E, didn't you?
Sí, había dicho sí y
That's C. What do you
verdad.
think? So you got it, kind of?
Sí, este se me hizo un poquito más complicado.
¿Yo lo hice más complicado o tú lo hiciste más complicado?
Yo lo hice más
Okay.
complicado. Usted lo hizo más fácil, lo entendí mejor.
Okay, perfect. That's good. That's good. That's fine. So correct your thinking, and we can do one or two more, right? So we can stay with 5.
Ujú.
And then maybe in the week, if you want to meet, we can do problems in 6 too. You can let me know, okay? Me puede contactar. Any students can let me know. We can meet in virtual reality. We can meet here to
Sí,
solve some problems.
thank you.
All right, let's look the rest of the test. Let's keep going. So this one is similar to the first one, so I'm not going to do that. Okay, this is a good one. Try this one. I'll give you 5 minutes. Maybe I'm going to press pause on the video. That way it's easier to watch. Okay. Okay, so it tells you X follows a left skewed distribution. You don't know the shape, but you know that it's left skewed. You know its mean and its standard deviation. Hold on, I have to cough. Sorry. So we take a random sample from there. Of 2,500. And we make a histogram. So we draw randomly 2,500 observations and make a histogram. What do we expect to see? So what happens to X? So this is what I'm trying to figure out. Given a variable with this distribution, what happens if we draw, and we make a histogram of those values that we draw? What happens? Well, we didn't learn about that exactly, but I think it's pretty clear. So we learned if we have a normal distribution with a mean and a standard deviation, and we take a sample, then the sample mean will also be normal, same mean, but a smaller standard deviation. That's what we learned. We also learned that if X is, we don't know the shape, but we have a mean and standard deviation, and we take a sample, then the sample mean is approximately, even though we don't know the shape of the original distribution, as long as the sample size is more than 25, then the sample mean, so a distribution of the means of the samples. In other words, if I was to calculate this is sample number 1. Okay, sample number 1. And I get an X bar from there. So this would be for number 1. Or let's say, not call it number 1, let's call it sample A. And then I can do it again, sample B. Now these are not necessarily the same number, so I'm going to put an asterisk here just to say it's not necessarily the same value. It could be, but not necessarily. And that would give me the mean of sample B. And I'm going to do that many, many, many times. All possible samples, all combinations of the values. Then I'm going to calculate all possible means, and then I make a histogram. the histogram will look approximately normal with a mean of mu and a standard deviation of root n. That's what we learned. We didn't talk about taking a distribution and just taking a sample of the distribution because we already know what to expect. This will look the same. It won't have changed. This will still be 150. It's a trick question because I didn't say anything about taking the sample means or the histogram of the sample mean. I just said take 2,500 observations. So, okay, so approximately normal, no. Left skewed mean close to 100 and standard deviation close to 50. What do you think? I think that's the answer. All right, so we didn't use this theory because it's asking you for the distribution of the original distribution. It's asking you for a sample of the original distribution. It's not asking you for the sample means. All right. So it would have to say, we take a sample or the distribution of the sample mean would have what shape, something like that. That's what it should say. It doesn't say that. And in that case, you would pick the distribution of sample means. The mean would still be 50, but the standard deviation would be the original sigma divided by square root of n, which would be 100 divided by square root of 2500, which is going to be, what is that going to be? 500? 50, sorry. So this is 2. So which one's this 50 and 2 or 0.2? Something's wrong with what I'm doing here. Anyway, that's not the answer. That's not the question, so that's not the answer. Because this would be the sample mean, the mean would be the same, and the standard deviation would be 100. Oh, sorry, no, the standard deviation was 50, not 100. That's what I did wrong. Now that makes more sense. So even though it looks like that should be the answer, 100, how did I screw this up so bad? This is the mean is 100. Sorry. And the standard deviation is 50 over 2500 is 1. So approximately normal with mean close to 100 and standard deviation close to 1. So E would be the answer to this question. But that's not what they asked you for. So the distribution of, it would be approximately normal. Okay, is that confusing? So it's a trick question, Natalia. Knowing one distribution and sampling from it, you can only expect the sample to look like the original distribution.
Estuve un poco confundida con este ejercicio.
basically, this is what we learned. But the question is not about that. The question is about just taking a sample from a distribution, and what would you get? You get the same thing. Nothing changes, no cambia, nada. Okay? It's just
Sí.
the same. If that's the whole principle. If we go into a distribution and we sample, we're going to get the distribution if we take enough. And we're taking 2,500, so we expect it to look the same. But what we learned about is if we have a distribution and we take a sample and calculate the sample means, the sample means will be closer together. Anyway, if you don't understand, then go back and watch the videos again on this stuff, because it's all in there. But
Okay.
basically, this is what you should be using if they ask about the sample means. But it doesn't ask for that. It just says take a random sample of 5,000 observations from the distribution and create a histogram of the data. So it just wants you to make a distribution, a histogram of a sample of that distribution. So you expect it to look the same, not too different. So you just repeat. It's going to be still skewed to the left, 150. So the answer is B. Nothing, they did not ask for the sample means to invoke this theory that we learned about. All right, let's see. Let's try number 5. Okay, let's try number 5. But this is 6. This is unit 6, so let's not do that. All right, here's a good one. So which of the following variables has a normal distribution? I have to make it a little bit smaller, but it won't. So which one has a binomial distribution? To have a binomial distribution, it should have, you should be able to find N and P. All right, let's look together. For A paperboy delivers a newspaper to every house on your block. X is the number of houses that get their newspaper on time tomorrow morning. So trying to find, what are we looking for in this problem? So if you can fill this in, number of successes in N trials, it doesn't mention how many times. We don't have N. But what are we looking for? What's the thing of interest? Number of houses that get the newspaper on time. So newspaper on time could be the success. So N would be the number of houses. And P would be the probability of getting okay. So the rule is N has to be known and has to be finite. It can be an unknown amount of times and it cannot be infinite, okay? And P must be known. If it doesn't give you the number, it should at least say that it's known. And it should be the same for every trial. Now, in this context of this A, do you think that's true? Is N known and finite? Is P known and the same for every trial? Oh, I'm losing the connection, it looks like. What happens if I do this? Oh, I'm gonna lose it. Oh, there it is. Okay. So that's how you have to think about A. Let's try B. Let's just skip that for a second. Let's try B. So B, you repeatedly flip 2 quarters simultaneously until both quarters land on heads. So try and define the success. Both quarters are heads. Do I know N? Do I know P? That's how you have to think. If you can put it, basically read them all and lay it out, what's N, what's P, and just try and find the most clear one because they're very foggy, very foggy. Probably not those. You roll a fair dice, 5 fair dice, each with a face value of 1 through 6. The total number of dots facing up on the 5 dice. Is that a binomial? I can't even put that in the context of binomial right now. Let's try D. An unprepared student randomly guesses the answers to each of the 30 multiple choice questions on the final exam. For this one, success is equal to correct guess on a multiple choice exam where they don't know anything. So for the correct guess, could we know N? Could we know P? Well, there's N is 30, so you're going to try 30 times to guess. And the chance of getting it correct depends on the number of options. Like if you're just guessing, so for example, let's say there are 5 options like now, right? So there's 5 options. So the chance of getting it right, if you're just guessing, is 1 in 5. That's how we would say. So I didn't give you that it was 5 options, but you should be able to calculate that if you knew. And then X is the number of multiple choice answers the student gets correct out of 30. So I think this is the best one because I can easily get N. P, depending on, I could calculate P if I knew how many options there were. A, B, C, D, E. So this so far is my best guess at a binomial. So the other ones might seem close and you might be able to see something, but it has to be very clear, all right? Let's keep going. E. You monitor the weather statistics every Saturday in Winnipeg for a year. X equals the number of Saturdays during the year that it snows. So this one I'll describe because remember, N has to be known and finite. So if we're going to look at all Saturdays in a year, we could get this number. We could get it. So it's not in the problem, but we could get it, right? How many Saturdays are there in a year? But then P has to be known and the same on every trial. If we're going to look on Saturdays every year in Winnipeg, Winnipeg is in Canada. It's my hometown. It's freezing cold there in the winter. And I'm going to look for snow. Is the chance of snow going to be the same in January Saturdays? And what about the February Saturdays? What about the March Saturdays? And then the June Saturdays? Is P going to be the same all through the year on every Saturday? What do you think?
No.
No, it changes, right? So
Mhm.
this one we know is not binomial because even though we could find N and count how many Saturdays there are, we know that P changes. The probability of snow changes over the year. So this cannot be binomial. Similarly in, there was another one. A. Think about the paper boy delivering newspapers. The chance that the newspaper arrives on time for the first house at the beginning of the block is higher than the probability of the newspaper arriving on time on the last house. So again, this is not binomial because P changes depending, I'll just say it's higher at beginning of the street and lower towards the end, right? It gets lower and lower and lower. Depends how big the street is. So even though it might be slight, if it's a small street, it changes. So that's not a binomial either. Are you getting the hang of this? So you gotta find n, or think about, can I know n or find it out? Probably. We could find out how many houses there are, right? So this could be, we could find this. In C, what's the problem with C? So let me first say this one is this is the answer here. So A is no good, B is no good, E is no good, and D is the right one. So what's wrong with C? With C, the problem is that even if we call n 5, so we're going to treat every dice as a different trial. The problem is that we have not defined our success very well, because we should be counting the number of successes. We have not defined what a success is exactly. This is counting the total number of dots facing up. It's not counting the number of successes of certain number of dots. So the success should be what we're looking for. Each roll, we should be looking for something, not the total rolls. So this is the problem here. So we're going to just say success is poorly defined. So there's my answer. So the correct answer was the easiest one. I put this in the wrong place. Let me move this up. Just for the newspaper. And this. So I know I have in the video also a discussion about identifying a binomial. I don't know if the thing moved or. For A was the newspaper. For B, success is both quarters are H. And even though we could get the info, I don't think I did that one. So this, I marked, for some reason, I read the thing about but I marked the wrong problem. So that's there. I didn't do this one about the H's, heads. So it said, success is defined, both quarters are H. The problem here was that I think we keep rolling, so we don't have that. I was writing these answers for the problem about the newspaper. So let me remember. So A was about the paper boy. B was about flipping two quarters simultaneously until both quarters land on heads. That's the problem with B, is N is not known. You don't know in advance how many times you're going to try. Okay. You should know N or be able to find it. Just flipping and flipping until you find N that way. That's not the idea. You're supposed to try a number of times known as N to get what you're looking for, to count the number of successes. Okay, so this is also wrong. So basically the problem here is the N. Okay, any questions about this one? You're going to think about this one? Just read it until you find one that is so clear it makes sense. And the other ones, you don't have to prove why they're wrong, but I'm trying to help you in general understand why they're wrong.
Sí, sí, sí lo pude entender y sí lo pude visualizar, se me hizo más fácil, porque cuando me lo pusiste ahí yo no sé nada, pero
It's
ya.
really hard. It's really hard without, like, I'm showing you here, even though we don't know N, you could get it, right? But P will change. That's the important thing. But reading all of these, they all look bad because all the information looks like it's missing. But the idea is, can I understand N? Can I find N? Yeah, you could find N, and it's finite. But the problem is P. In this one, there's no N. P, we could figure it out. We could calculate P, but to get 2 quarters or 2 heads, we could figure out the probability for that one. Here is just N is what is C? Success. There's no, it's not clear what is success is here for each trial. We just get that. We got that. I'm sorry, I have a fly. We just have the information about the total number. Like we throw them all, that's 5, and then we look one at a time, and we're not interested how many times we see a 3 or how many times we see a 5 or how many times. We want the total count on the dice. That's not, we're not supposed to look at the total. We're supposed to look at each trial. That's the problem with that one. So poorly defined success per trial. D is the answer, and this one is no good because like A, E also changes, P changes. So as much as you didn't have a clue at the beginning, I think you get it now, or better idea. So do you want one more or do you want to stop?
Yo creo que stop.
Okay, we can stop and then contact me so that next week we can see you again. Okay, Claudia? Claudia's there too. We'll see you again maybe before the test, maybe Monday or Tuesday, we can meet. All right, so let me know on the weekend.
Sí.
Text me.
Sí, sí, don't worry. Thank you.
Okay, bye.
Buenas noches, gracias.
Okay.